Professor Diane Larson Freeman, thank you so much for being here with me, supporting this project.
Thank you.
I would like to start, I don't usually do this, but I would like to start this video by mentioning some of the misconceptions that haunt CDST. But because I think misconceptions haunt most theories, but CDST, in my opinion, is particularly haunted by a number of them. So, for example, people might hear things like, it's just a metaphor. It's like weather prediction. It comes directly from physics. It's a quantitative theory. It focuses too much on language use instead of language learning. It says nothing is predictable. It has nothing to say about pedagogy. That last one kind of hurts. It seems that this discourse may prevent some people from engaging with the theory. But on the other hand, many people are increasingly being interested in this theory. I've seen students flock to Phil Hyver's presentation on CDST in the hundreds. And I've seen some theses, even in this university department, claiming to use CDST. But as Al-Houri, Hyver, and Evans warn in their scoping review of 25 years of CDST research, sometimes there are people hoping to adopt the framework, but not really demonstrating a sufficiently deep understanding of it. So when it comes to CDST, I would like to perhaps warn the audience that unless they've spent a decent amount of time trying to learn about the theory, most of what they've heard may be mistaken. And that's number one. And number two, that CDST is not the borrowing of a physics theory into L2 studies, but is part of a wider scientific phenomenon, which is the introduction of complexity approaches into the many social sciences, sociology, psychology, etc. A development that has very interesting and powerful consequences for the way in which we engage in scientific inquiry. Professor Larson Freeman, perhaps we should start from the beginning. What was the theoretical landscape in SLA when you started to be interested in complexity approaches? And what sort of advantages do you recall finding in this approach that other theories could not offer?
Great, thank you. I can certainly understand that an initial acquaintance with complexity might lead to these conceptions, but indeed, as you say, they are misconceptions. I think this will become clear as we proceed. First of all, thank you for this opportunity. Cesar, may I call you Cesar?
Of course.
Thank you for this opportunity and all the work that you've done to prepare for this. It does show, and I'm impressed. I've written out some of my answers, at least some notes, because it's important to me to use this opportunity you've given me to dispel the myths, or at least the misconceptions, or at least try to. Now, for your first question, when I first encountered complexity theory, there were a number of SLA theories abounding around us, but dominating the landscape was a mentalistic view. Acquisition was conceived of as a cognitive process that was essentially context neutral, an attempt to acquire a rule-governed competence. My research at the time found a frequency effect on the morpheme accuracy order. And it was a correlation, not a causation, but it made me realize that the internal process had to have a source outside, right? The frequency effect. And I realized that, but I also realized that frequency was an ambiguous finding. I mean, after all, frequency could support a rule-governed approach to language. That is, the more opportunities a learner had to encounter the structure, they would perhaps learn the rule with greater facility and greater ease. Or it could support a stimulus-response associationism explanation. The more opportunities to encounter the structure, the strengthening of the bond between the stimulus and the response. In other words, frequency was a finding, but it was in need of a theory to interpret it. A second part of the landscape was an essential bifurcation in the field. Evelyn Hatch pointed to this at the very start of a modern day study of second language acquisition. The bifurcation being, on the one hand, researchers who were looking at the language learning process. And on the other, researchers who were investigating individual differences in learning in second language acquisition, with the goal of trying to understand the differential success question. Why is it that certain learners are more successful than others in acquiring a second language? Now, this is an important question, but in fact, what was achieved was ever lengthening lists of individual difference factors, and even those were complex in themselves. And again, I was doing research at the time in the process, and I was attempting to answer Kenji Hakuta's call for an SLA index of development. And even though it wasn't research focused on individual differences, it was clear to me that any category we used was heterogeneous. We would not find learners behaving in the same way. That was an important lesson as well. And a third feature of the landscape was the call to follow a natural approach in teaching and do away with a focus on grammar. I found this distressing because I agreed that perhaps grammar instruction wasn't always successful, but I argued that it was the way it was taught, not necessarily grammar itself. And indeed, as a teacher, I want to respond to the learning styles or the proclivities of all my students, and certainly some of them benefited from an explicit focus on grammar. So that was a third feature of the landscape that I was puzzling about when, quite by chance, I read James Blake's book, Chaos, the Making of New Science. Now, this book had nothing to do with language. It really didn't. But I believed I found the theory that I was searching for, complexity theory. And I began to read everything I could on complexity theory. It helped me understand frequency. I had a theory to interpret frequency. It was an anti-reductionist theory, so it argued against the ever-increasing, ever-lengthening list of factors that contribute to second language acquisition. I'll have more to say about that later. And it was a dynamic theory, it was the theory of dynamism. And there on page 24, Blake had written the act of playing the game as a way of changing the rules. And on the basis of that, I went, yes, we should be teaching grammaring, ing, not the static rules of a pedagogical grammar. So after reading and thinking about these, I gave my first paper, Chaos, Complexity Theory, and Second Language Acquisition in Montreal at a second language research forum in 1994. And then that paper was later published in 1997 in the journal Applied Linguistics. I think I found the theory I was looking for, and I wanted to share it with others.
There is this idea that CDST is only a metaphor. I think this is often used as a sort of criticism, but I would argue, as other people have in the past, that language itself is a metaphor of reality. And since all theories are explanations that exist through language, then in a way, all theories are metaphors. Would you agree with this statement?
I do agree, Cesar. I go even further, though, and quote the eminent biologist Richard Lewontin, who wrote that it's not possible to do the work of science without using a language that's filled with metaphor, so even beyond the theory to the whole field, whole discipline. And dynamic systems theorist Phelan wrote, all theories are metaphoric. Now, the dominant view in SLA, as I mentioned in my first answer, my previous answer, was mentalistic. And the metaphor was that the mind is like a computer. We have input, we have black box, which is the mind, and then there's an output. Now, that was appropriate for the time. A mechanical metaphor that drew on computers was appropriate for the time. But instead, these days, CDST adopts an ecosystem metaphor. And the one I like to use is Phelan's mountain stream. If you think about a mountain stream moving all the time in continuous flow and continuous change, you can easily see how that's true of language use and language development, all the time changing, all the time flowing. Furthermore, like a stream, whatever happened in the past influences the present and indeed the future. So in the case of a stream, you have snow falling in the mountains the last or previous winter, that then melts in the spring and feeds the stream so that the flow is continuous. Although it rises and falls, of course, with the amount of snow that's fallen and the particular temperature at the time. Notice the stream also, besides having a temporal context, that's what I wanted to say, besides the stream and language having a temporal context, both have spatial patterns. Both have spatial patterns. We can see places, for example, in the stream, the water is moving rapidly. At other places, there's a stillness to the water. And like the stream, language development also has recognizable patterns, U-shaped patterns, bifurcations, plateaus. In the stream, one such pattern is an eddy, a kind of whirl in the stream, especially where the banks of the stream are high and the stream contour changes. Notice that the water passes through that whirl, that eddy, but the eddy, the pattern endures. It's a dynamic pattern. The eddies in the stream are what I call patterns in the flux. And clearly, that is what language is. It consists of patterns in the flux. Indeed, I think several people would relate to this particular idea. For example, Isabel Tasker in her study on Chinese learning in Australia. So I think it's more a case of choosing your metaphor. Lakoff and Johnson, of course, have shown the ubiquity of metaphor in language. As I mentioned earlier, the view of SLD, second language acquisition, being mechanistic, the metaphor was a computer. This is challenged by complexity, which relies more on an ecosystem metaphor, wherein there are many elements which interact in dynamic and adaptive ways at many levels and at different timescales.
CDST is often conflated with chaos theory, which is a mathematical theory or a theory in mechanics. CDST, on the other hand, was explained to me by Phil Hyver as a much broader concept, or as a much broader approach, one that studies two main things, relationships and change. What has been your position on the use of mathematical approaches and statistics in the social sciences and in applied linguistics? Is CDST a quantitative theory?
No, it isn't. Following French philosopher and complexivist theorist, philosopher Edgar Morin, complexity theorists make a distinction between restrictive complexity and general complexity. Now, restricted complexity does involve a strict mathematical application. In fact, unfortunately, sometimes it's called dynamical systems theory. That adds to the confusion. One that advances formalism and modeling, but one that remains within the epistemology of classical physics and mathematics. That's restricted complexity. In contrast, the one that CDST researchers follow is general complexity, which is operated ontologically and epistemologically differently. It's largely inspired by the complex means through which nature regenerates and maintains order under constantly changing conditions. The result is a transdisciplinary theory, which represents an important challenge to the disciplinary silos of the academy, according to Byrne and Callaghan. In fact, Stephen Hawking, how about that for an authority? Stephen Hawking called this century, the one that began in 2000, the century of complexity. This is not to say mathematics has no place. Quantitative changes over time can give rise to qualitatively new behaviors. However, numbers are just symbols. They're just concepts. In a recent AAAL, American Association for Applied Linguistics seminar, Professor Kate Yaw made the point that quantitative research often occurs under, quote, the illusion of reality. Quantifying a phenomenon, in other words, does not make it objective reality. Numbers need interpretation, and we need to be strategic in how we quantify phenomena. Indeed, there have been innovative methods used in CDST that use numbers, min-max graphs, power laws, Zipf-ian distributions, fractals, and excellent examples of the application of math to CDST could be found in Ivor and Al-Houri's book in 2020, and one about to come out by Loie DeVilde and Rasmawati, based on an ILA symposium. So numbers come in, but it's not a mathematical theory the way, as you say, chaos theory is. Also, we can use numbers in a mathematical sense, an experimental sense, for example, but CDST researchers frown upon that because we know the difficulty, we know how much statistical significance can be affected. That certainly came out in the big controversy in the early 2000s, Ioannidis' 2005 paper showing that there was a lot of problems with psychological papers based on statistical significance, which can be affected by, for example, sample size. So numbers themselves are not, as Kate Yaw said, they are not reality. We need to look behind them to see what they represent. And again, chaos or complexity theory, especially in the general sense, is not a mathematical theory.
In your 2008 book with Lynn Cameron, you warned that we should always be aware of what our metaphors allow us to see, as well as what they may accidentally hide. We will explain CDST a bit more in part 2, but as a general preview, what would you say CDST allows us to see, and what could it potentially hide?
Thank you. So one of the lessons of CDST is the need to account for the non-duality of phenomena, to seek complementarities rather than dichotomies. Indeed, within a relational theory, such as complexity, efforts are directed towards identifying how distinct constituents of a whole relate to each other, as you just said. So we look for connections. It's not social and cognitive, it's socio-cognitive. It's not learners and learning. The learner learning in a context is the fundamental unit of analysis. It's not grammar and communication, it's grammaring. It's not language and culture, as Agar said, it's lingua culture. And even, as I said a moment ago, you could argue that quantitative and qualitative are linked. So we were looking for overcoming the dichotomies and looking for what connects. CDST also invites us to look for dynamic patterns, the developing language of learners. Remember, I call them patterns in the flux. Relatively stable periods or attractors, but also repellers, connected growers, fractals, bifurcation. It helps us to see how fixed forms or stable forms are broken up, the chunks of language are broken up, not reconstituted. I've written about not transfer, but transformation. Not conformity to uniformity, as I've written, not conformity to an end state target language. The learner's quest for increasing functionality is what moves it forward, moves the development forward. So we can see evidence for the CDST claim that all interactions involve mutual influence, some in the form of co-adaptation. We see a lot of synchronization of behavior. All this we can see with CDST. Now, Cesar, you ask what can we not see? I'm sure there are a lot of things. I don't think any one theory will cover the whole landscape, as you say. And of course, we, as we move along, we understand theories better. I certainly understand a lot more with complexity theory than I did in 1970. Well, 1997, let's put it that way. One thing that's not in the theory is the important challenge to fight injustice. It's not contained in CDST itself. Though an understanding of complexity can contribute to the fight against injustice. For example, complex processes are all about change. Since emergent processes are not fully determined, they contain within themselves the potential for freedom from repression or freedom from discrimination. In other words, they're open. Secondly, it's well known that diverse systems are more robust. Complexity theorist Scott Page has written about this. He has a whole book on this. Think of the vulnerability of monocultural agriculture
Mhm.
and the robustness of polycultural. When many crops are planted together, obviously polyculture is much more robust because a single infestation can wipe out a monocultural agricultural system. Fighting injustice, therefore, is not part of the theory itself. Nonetheless, recognizing the possibility of change, the potential for change, and the value of diversity can certainly encourage us. And as Varela, Thompson, and Roche observed in their important book, The Embodied Mind, quote, knowing how to negotiate our way through a world that is not fixed and pre-given, but that is continually shaped by the type of actions in which we engage is a challenge of being human.
I think some people don't engage with the theory because they believe it's absolutely anti-reductionism. But what I think people often miss is that, and the reason why I include this topic in the first video about the foundations of the theory, is that providing a critique of reductionism is not exactly the same as calling for us to get rid of it. So is CDST anti-reductionist?
Yeah, thank you. Some have criticized CDST, saying that it's impossible to study a complex system in its entirety. Therefore, reductionism is needed. However, the same critics are not using reductionism in the way that CDST theorists do, or the way that mainstream positivistic science does. And therefore, they misunderstand CDST's position. A measure of success in the physical sciences, in physics, for example, is to be able to make simple causal statements at the lowest possible level. This is called ontological reductionism. It's the one that CDST pushes back against. For example, this kind of reductionism fueled the search for the Higgs boson particle. And its success, the success of the search, confirmed physicists the mechanism that gives most particles their mass. So for some things, ontological reductionism works very well. It works to attribute a consequence to a single cause, but it cannot stand for the whole of reality. Indeed, the quest to understand second language development is not the same as the search for the Higgs boson particle. And as I said a moment ago, it is this ontological reductionism that CDST rejects. It's obvious to me, I think to many today, that seeking answers in our modern world require a new mode of thinking. Human has written, what current processes of globalization and global warming are bringing forth is a need to develop means by which we can better understand the complexity of the world around us, which is not reducible to some central or single essence. Rather than seeking to understand complexity through reductionism, then the world today requires a more holistic, ecological, and relational system to count, at least as a complement. And I think, I'm calling this new, but I think the indigenous people of the world have often subscribed to a theory or a philosophy or an ontology that does recognize the interconnectedness and the relational account. As an ecological theory, CDST recognizes that as second language development does not take place in static isolation from what's happening in the temporal and spatial environment in which it's situated. Rather, it's emergent from a dynamically interconnectedness with the environment. A change in any internal or external component of the developing system affects the others, often in unanticipated ways. Furthermore, the learner is not just a combination of variables, as Benson wrote. Thus, at its core, complexity theory challenges the notion that by perfectly understanding each component part of a system, we will then understand the system as a whole. Miller and Page quoted Sufi poet Rumi as writing, and I quote, "One and one may well make two, but to really understand two, must both understand the nature of one and the meaning of and. Such a statement underscores what I've already indicated is a fundamental quality of complexity theory, that it is relational. It's from the components and their relationships that the system we're trying to understand emerges. If we isolate the components artificially, we lose the essence of the phenomena we are attempting to describe. This is a form of reductionism that CDST pushes back against. As you have written, Cesar, in your wonderful book online, in CDST, attention shifts from parts to the interactions and relationships of parts. In other words, what becomes fundamental to explanation and causality is not the small fundamental parts that give rise to everything else, but rather the multiple and variable relationships that give rise to complex kinds of causality. Requena Ramos, 2025.